by popular demand, here's a quick PCB exposure with the Elegoo Mars LCD resin printer. I have actually gotten rid of my entire DIY PCB etching infrastructure, because JLC PCB and the others are just way too good, fast and cheap, and it just doesn't seem worth it anymore to mess around with all the chemicals and special machines. But the DIY PCB era was a good time, no regrets. So the UV LED in here is a big one. It has an area, and it's not a perfect point source. That means that the shadows cast by the LCD are going to have blurry edges. But the closer you can get the masking layer to the photosensitive layer, the less you'll see from that problem. I'm going to use the standard 60-second first layer exposure time, because that seems reasonably close to what I used in my old fluorescent lamp-based exposure box. Little bit of sodium hydroxide in tap water as a developer. Told you about the absence of my infrastructure, haven't I? Attempt number 1, as you can see, was a negative. Attempt number 2, huge success. Some AA retail packaging and ferric chloride for the etching. Higher temperatures and agitation can accelerate that process. It's 36 degrees C outside today, that'll have to do. It's not a crazy intricate design or anything, just some optocouplers connected to my motion controller FPGA card. I'm so making an entire video about that thing and its integration in Linux CNC. That was quite the adventure. The story behind the optocouplers is, I just want to pull low some normally high 24-volt inputs of the servo drives with the FPGA card and its 5-volt tolerant GPIO pins. And there we are, back on topic. I spent an absurd amount of time making the servo drive in and output cables as nice as possible. I went with a shielded cable with 16 twisted pairs, so that nothing can get in the way of absurdly high step frequencies and encoder feedback at maximum resolution. I'm putting everything into a separate control cabinet, but that part is not particularly nice yet. It consists mostly of upcycled components and a big old Office PC mainboard. It's a bit sketchy. I'll nicify that for our Linux CNC FPGA card video. But this is where it'll live, I think. It's a bit of a cabling nightmare already, and I haven't even connected limit switches and a hand wheel. Speaking of which, beautiful Japanese inductive proximity sensors. And these guys speak some sort of CAN bus dialect and will need some logic analyzing before being useful. But we don't need any of that for our first chips today. I'll post another livestream link in a moment. This is a safety relay. It wants all of its inputs to be high before giving the all clear to the spindle VFD. One of the inputs is connected to the water chiller, so that over temperature or flow rate falls can halt everything. The first thing we've got to do is get rid of that ridiculous 3D printed motor mount.